Okay, the next one, position versus time graph, shows the motion of a vehicle. During which section does the vehicle have the greatest velocity? So has the greatest velocity during section 3, because that's where the slope is the highest, which means I am covering the most position in the least amount of time. So 2 points, one for the answer, one for the explanation. Okay, velocity versus time graph. What is the distance traveled? Show your work. So for velocity versus time, the distance traveled is the area under the graph. I looked at this as two separate areas. One is the rectangle from 2 to 5 seconds, and another one is the triangle from 1 to 2 seconds. And so the area of the triangle is 1/2, the base is 2 seconds, the height is 8 meters per second. So 1/2 times 2 times 8 is 8 meters. And then the area of this rectangle, 3 seconds, is my base. 8 meters per second is my height. So 3 seconds times 8 meters per second is 24 meters. I add those together and I get 32 meters. What is the average speed of a car that moves 350 meters in 36 seconds? So this is the definition of average velocity, is distance divided by time. 350 divided by 36 is 9.7. So again, 1 point for the answer, 1 point for showing the work. This one, people had interesting things. So you're supposed to identify which runner and also why why you identified that graph. So positive acceleration during the 3 seconds was Marcelo. And the reason we know that he had positive acceleration is because the slope of the line is increasing. People had a couple of other answers for that were also correct. He's covering more distance in the same amount of time. That's also good. Negative acceleration is Ismail. And the reason why is the slope is flattening out. So basically he's coming to a stop where his position is not changing very much between like 2.5 and 3 seconds. I said the slope is flattening, slowing down. Zero acceleration is Dwayne. The slope of the line is constant, which means that every second he's covering the exact same amount of distance. So 2 points for each part of this, 1 for the right runner, 1 for the right explanation, 6 points for this question, 13 points total on this page. Okay, we've got 3 rows of graphs, and the first thing you're supposed to do is describe the motion, not the graph. So graph F, position is not changing over time, and so that's at rest. Graph G, constant velocity and moving in the negative direction. So those are constant velocity, negative direction. And then graph H, moving in the negative direction, it's a negative slope, and the slope is increasing, so it's speeding up. So speeding up, negative direction. So 2 points, 2 points. So which are the best match? So F is at rest. It can't go with any velocity graph, so that gets rid of A and D. And then G is a constant negative velocity, which only goes with graph R, constant negative velocity. So that gets rid of G, or B and E, and so that means C is the correct answer. Okay, roller coaster starts from rest and accelerates downhill at a constant 8 meters per second squared for 5 seconds. So it starts from rest, so my initial velocity is 0, so you get a point for doing that. And then negative velocity, so -8, or negative acceleration, each second it's increasing 8 meters per second. So -8, -16, -24, -32, -40. So I gave you 2 points for your numbers and then 1 point for having negative numbers. And then it goes uphill with a constant acceleration of -3 meters per second. The thing to recognize on this is that going downhill had the opposite sign of this, and so I had 8 and then -3, and so the numbers had to get smaller. So I went from 40 meters per second to -37 to -34, -31, -28. Again, 2 points for the correct answer. If an object starts accelerating from rest at a rate of 34 meters per second, how far does it travel during the first 3 seconds? And so this is the formula that you're going to use because my initial velocity is 0. So you just plug in the numbers and you get 143 meters. Which of the following objects are in free fall? So free fall means the only force acting on it is the force due to gravity. Does not matter which direction it is traveling. So only force is a force due to gravity. So that would be B. The ball has been tossed upwards. C, cannonball has been shot horizontally, it's in the air, and then E, a physics cart is dropping. So B, C, and E only have gravity working on them, and so those are the ones that are in free fall. Total on this page is 18 points. 29, toss a 0.3 kilogram volleyball straight up at 3 meters per second. We're in free fall, so that means the acceleration is the acceleration due to gravity, so we're at minus 10 meters per second. How high does it go? So I know my initial velocity is 3 meters per second. My final velocity is 0 when I've reached how high does it go, and that is g. So I'm going to use this equation. My my final velocity is 0, and then I'm going to subtract v0 from both sides. So this is my first isolation, and then since I'm solving for dx, I'm going to divide both sides by 2a, and so I end up with this. And so delta x, plug in my numbers, and I get b. I drop a 15 kilogram box off the Eiffel Tower after 6.6 seconds. How fast is the box moving? The mass doesn't matter. Again, I'm going to do like the usual thing that I start with. V0 is 0. I don't know my final velocity. Because I'm falling, I know that A is minus 10 and my time is 6.6 seconds. I want to know the final velocity, so I'm going to use this equation. V0 is 0, minus 10 times 6.6 gives me negative 66 meters per second. All right, Ariel's puppy weighs 15 pounds. Heather's puppy weighs 15 newtons. It doesn't matter whether you put Heather's puppy into pounds or Ariel's puppy into newtons. I did Ariel's puppy into newtons. So 15 pounds times 4.45 newtons per pound gives me 67.75 newtons. That is a bigger number than Heather's puppy, so Ariel's puppy is heavier. 32, 100 kilogram astronaut weighs 500 newtons on a different planet. So what is the astronaut's mass on the planet? It's 100 kilograms because mass never changes. And then what is the acceleration due to gravity? So we use this FW is equal to mg, but now we're looking for g of the planet. Remember, g is only negative 10 on the Earth. So I do FW, which is that, divided by m, which is 100 kilograms, and I get 5 newtons per kilogram. Child sits on a tire swing that is suspended by a single rope from a tree branch. What is the tension in the rope? If the mass in the child is 41 kilograms. So I know that here's my child. Her weight is 41. If she's not moving, that means the tension is the same. And so Ft is equal to Fw. We just saw above that this is m times g, and so m is 41, g is 10, so it gives me 410 newtons. Needed to have a free body diagram in order to get all the points, because you have to show that the weight force is equal to the tension force. And then Jim passes 0.64 kilogram basketball to his teammate by applying a force of that. So I'm going to do F is equal to MA. I'm solving for A. So divide both sides by M. So 54 newtons divided by 0.64 kilograms gives me 84.4 meters per second squared.